Hello everyone, welcome to the next video, and this video is about PZEM-017 energy meter. And this meter reads energy, DC energy, direct current energy. It will give you volts and watts and amperes and watts per hour. Yes, model number is PZEM-017. I had some problems uh, reading its data on ESP32, so I decided to create a video for this so that it will be helpful for others also. So the content of this presentation is about credits, hardware, wiring, software, Arduino libraries, and Windows software, PZEM and QModBus. So let's start with the credits. So this is the uh, website which has helped me a lot in this solution, and I have modified their solution to my needs. So this is the link. Let me click on it and open up the website, and we will be coming back to this website time and again. Let me walk through the website. So this is about 017 model, and this is the PZEM software, and this is their Arduino, and they are showing the two types of modules. I will be using this one, and you can have LCD display and some button controls, and this is the wiring they have done, and then they will show you how to use Arduino. So we will get back to this page. Let's continue with our presentation. So I will be using ESP32 and this UART to TTL module, this one. The four wires are connected on the left and three on the right. And when we talk about Windows applications, we will be using this USB2 RS485 module, and obviously the 017. So this picture says this is 003, but actually this is 017. To take it as 017. So first of all, the wiring diagram. The first wiring diagram is the Arduino or ESP32 to UART RS485 module. So the 5 volts will connect to VCC, ground will go to ground, the IO pin GPIO 17 or TX2 will connect to TXD, and likewise the RX2 to RXD. So these are the 4 wires you will connect with this module. And then we will then this module, let's go talk about how this will connect to the 017 module. So please see that the logo, this is upside down. So when and it is also flipped. So the thing you need to know is that 5 volt definitely will connect to 5 volt, ground will connect to ground, and A will connect to A and B will connect to B, just like in the previous where TX will connect to TX and RX will connect to RX. So this B will connect to this B, and this A point will connect to A point. This module will not work without input of 5 volts. So I provided 5 volts from my ESP32 board, and even when I was working with Windows. So this is the setup I have done. And when we will be using this USB module, in even in this module, A will connect to A and B will connect to B. So again, as I mentioned, when I was communicating with Windows, the 5 volts to this module was provided through my ESP32. So if you have an external adapter, that's fine too. Okay, I will not be using the shunt in this uh, video because I haven't used it yet. This video is all about how to read data. So once you connect that, you will have the data from the shunt also. But I will be providing 12 volts from external adapter, and you will notice that if this is flipped, if you notice the flip effect, if it's upright on the left, these 2 points will be used. When you flip, these will go down, and you can see this positive sign. So this positive sign will connect to your adapter's positive point, and the next one is the negative. So negative will be connected over here with the second point. Although this is saying left, maybe let me see. I think I should change this picture with PZEM-017. Maybe this is the problem. All right, I think this is better picture now. My mistake. I didn't realize that I have put on PZEM-03 picture. They all look like same. Anyways, so now you can see that there is a battery and the positive terminal is on the downside and this terminal is negative. So you can well understand that why I have connected positive and negative. So this will be positive and this will be negative. I will not be using the shunt just because I won't trying to get the readings. So if you connect the shunt, the readings will be upgraded automatically. So take care of the flip. When you flip, these will go up, and if you are looking from the back side, then these will be on the bottom side. So connect this adapter to the positive and negative side instead of the battery. And this is all the wiring you need to do. And this is the picture I got from this website. Let's go back to the website where it is. I think they have shown this picture somewhere, or it was some other website I got from. Yeah, maybe some other website, but this is the picture from the net I got, and this also helped me in the wiring. So when you will be using shunt, you can again refer to this, but this is how I have done for this project. Remember, I will be using in this picture, this is TX-RX. I will be using TX2 and RX2. And it's time to show you my mess, and this is how it looks like during project stage. So this is my adapter powering the PZEM, and then this is ESP32 connecting, and this is the TTL module. And you can see right away this is also connected with the Windows PC also. So during the test phase I could read the data on the PC and the Arduino. So when I was testing, I was just testing that if both are connected, and because I had difficulties in reading for Arduino, PC was just fine. It was quick. So if you face any troubles, remember, if this TX light is blinking on this module, this means that ESP is sending data correctly. And if this RXT is blinking, this means that PZEM is answering. So maybe you are asking the wrong question. If both are blinking, it means maybe that you are asking the wrong question and getting the wrong answer or something else. But for me, it was TXT that was blinking, and there was no response from the PZEM. So it took a long time to resolve the issue. So that's why I'm sharing this, that when ESP32 is sending data, this LED should be blinking, and when PZEM is answering, this RX should be blinking. Okay, so let's go practical. Step one, let's get PZEM software and download it. So from where we can get it? On this website, I will leave the link uh, in the description. You will get this software if you from here. So if you click on this, so this there will be a zip file download. Let's show this in folder. And, this is the file. Let's extract it. So this is the extracted file, and you can see there is also a word master in this. So don't get confused that this is Arduino library. This is PC software, and when we go into this, and you will see this PZEM-003 master, and we will use this application. So this is not 017 but 003, but this will work. So let's run this application. So one thing is you need to set COM port. So if I go to my device manager, here's my device manager, and I have COM5 and COM4. So one is the ESP32, and this COM4 I know is the USP2. RS4 to 435. So let's select COM4. Okay, and let's start our Maya. So as soon as I click on my start Maya, you will get the results. So this is simple. So this will get data on your PC, and this assures you that your module is fine and it is working, right? So I suggest that you first test this software. So once this is working, this means that your module is fine and it is working and it is getting all the voltages. So this is how I tested. So let's move to the next one, and the next one is also a Windows software. This is QModBus software. So this is very helpful, and where you should get it from the net, easily download it. Let me run this QModBus. This is the software. You will show it that you want to COM4. This is should be 9600, 8 and 2. Remember, this is 8 and 2. 017. So generally stop bits are 1. In this is stop bits 2. So you have to do this, and slave ID I know is 1, and read coils, this is, so if you want to send this, there will be an exception, there can be an exception, but you see the data right now, because Arduino is connected, so the data is coming and going both ways. So you can see some movement over here. So maybe you can say start address this and read some 10 lines maybe. And anyway, so this software is very helpful. This keeps monitoring your port, and this will give you the raw data. If even I can send some data to to PZEM. So if I send, so it's giving an error, but this actually helped me read and send data and see if the data is going through. So when I press send, the RX light on the module start blinking. So with this help of this software, I was clear that the wiring is correct, and the UART to TTL 435 board was working. So this is what I use this software for sending the data. So maybe this is helpful for some. Okay. The next and the important thing is our Arduino IDE and the ESP32. So let me get it ready for you. All right. So you need to go to this web address to get this library. But let me tell you that what is this library. So if you go on this website, solarduino.com, so when you go down where it is, so here they say that this is evertdecker.com, evertdecker.com maybe. Uh, so this is they have used their work, and you can download the original modified Modbus master library, and they have used this library in their coding or the project, and then they have altered it and create a new code. So their code is given here. What I have done is I have further modified it because the library name was same. So if you are going to use the Modbus master library, so there, this if you download this, you have to uninstall the earlier default library, and which I didn't want it to do. So I have modified its name. It's a bit different name. I'm not sure that you can use this libraries in one sketch together, but they can exist in your library together. You don't have to uninstall the earlier one. What I have done. And my code is derived from their code using these codes, because they were using this LCD and the button code. So what I have done is I have just excluded that code and made it a bit simpler. So all credits to these people. And let's go back to and show you how you can get my library. So this is the link. I haven't let me open it. And I have mentioned that I don't have the ability to branch out, and I haven't tested it. So instead of I was afraid that maybe I can I will do something wrong to their code. So I have created this different page for this library. You can download it. Let's download it. So you can there are some uh, JPGs. These are the same wiring pictures that you have seen in this presentation or video. So let's open. We don't have to open it. Actually, what we need to do is we need to import this library into our Arduino. Let me open my Arduino. So here is my Arduino IDE. So what I will do is I will go to sketch and include a zip library, and then I will go to my downloads, and where is my downloaded file we just downloaded. That was which one? No, it was ModbusMaster PZEM, right? If I so I think this is the one, right? It's main.zip. So I haven't, this is the first time I have downloaded it from my GitHub. Otherwise I was using the zip file. So let's uh, let's details, date modified, come on. And this is should be at the top now. Yeah, this one. So this is, let's open it up. and it does not contain a valid library. Great. So let me do one more thing. So let's try again. As I said, I am not very good at uh, GitHub, so let's add a library, but this time what I will do is I will go to downloads and I will say details modified, and this is the one we have downloaded. So if I go select it, this is not done. What I will do is I will go to here, right click, extract all. So if I extract this zip file, within the zip file, this is the ModbusMaster. So I have to import this one, not the main, but this ModbusMaster PZEM-017. This I have to include, and where is my, again going to sketch, include library. Oh, come on, add zip library. Again going to downloads. Come on. So details, date modified, and where is PZ main? I will go to this, and this is the zip file I want to import. This is the actually Modbus master PZEM-017 master. You should be importing this zip file. So library added to your libraries. So how we can check? Let's go to the examples and let's go to custom libraries. And you can see this is Modbus master for PZEM-017, and one is change address and other is the read values. So if I click on the read values, you will get this. So let me close the access files first, and this is the code I have shortened from the website. So all you need to do is, let me set it to compile while I discuss. So you can change the PZEM address. Generally is 01. You can change whatever you want, and actually don't want whatever the actual address is of your PZEM's device. Generally as a default it is 01, so here it is 01. I have a 200 ampere shunt, so this is the help given in the original file. So this should be 0002 because I have a 200 ampere shunt, and this is here. It's okay. So, and then this is the simple code you can understand, I hope. And if you don't use this, then you will not you will lose some, I think, shunt correct values, but the loop and the setup are very simple. So once this is done, let me upload, and let me set this is this, and this is code 5, I think. Yeah, com port 5. So if I open right now, there should maybe some values coming in. No. Yeah, so this code is already actually uploaded on the module, but let's change the address first. So let's go to examples and open up the change address. So this is my change address code. You need to mention let's put this on compile also. Well, only one compiler at one time. Okay, so old address is 01, and let me change it to 02. Okay, once the other one is compiled, I will send this to the compiler. Let's pause the video for a while. So I am uploading this code change address from 1 to 2 to my Arduino, and once the address is changed, the volts will be read from the module. So code is being uploaded, and you can see the volts is being read at as 12.8. So there is a delay of 5 seconds. So let's go back to our this code, and this one has slave address as 1. So let's upload this one also and see what will happen. And, can we have this comport? So it's uploading. Here is my comport 5 and says read, failed to read Modbus because of the address that has been changed to 02. So if I change it to 02 and upload it again, so this should start working. So if it's uploading, and you can see that data is coming now. So these are the 2 examples that are available with this library, and I hope this will be helpful. And let's close now, and let me correct the address in the background. Please upload it here, and let's close this one. Okay, no need. Cancel, close, no. Okay, so one thing, what if we don't download this and right click on this and say save link as? So if you download only the zip file, so it will be downloaded as zip. So if I go to, let's say, documents and save link as, you don't need this one because there's only present, there's one only already present. So if I delete this and then try to right click save link as, so this is the correct name, and this you can save this instead of going to code and downloading the whole. You need to download the zip file. So this is the library, and if you download this, so you don't have to bother about unzipping, extracting, unzipping, and then selecting the correct zip file. So just download this file. All right, so let's close this. And anything else left in this video? Yeah, we have discussed the applications, and that's it. I think you are good to go now. And if you like the video, think about giving a thumbs up or liking it. And if you haven't subscribed to the channel, think about subscribing to the channel. Bye for now.